right, we're going to look at some logarithmic and exponential equations. So this is just simply your handout that, if you remember, on one of the very last things I mentioned on the last lecture is that we said if we had the same bases, then actually these values are equal to each other and vice versa. So let's say, for example, we want to solve 2 log base 5 of x equals log base 5 of 9. Well, because we have the same bases, then we can use this definition up above, so what I'm going to do is I'm going to move my power first. So log 5 of 9. And now, based on up above, since we have the same bases, I can just simply set these equal to each other, meaning x squared equals 9. Remember, when you solve a square, you square root it. And when you square root, technically you're supposed to be doing the plus or minus, but the only key here is that, remember, you cannot take a negative log, and so we wouldn't count this one. This would be an extraneous solution, and we would simply discard it. Okay, let's look at another one. So let's say I want to solve log base 5 of x plus 6 plus log base 5 of x plus 2 equals 1. Usually the first thing you kind of want to do, because on that last one we talked about domains, is it's good to go ahead and find the domains first so you know which solutions you wouldn't be using. Remember that you cannot take the log of a negative number, which means that this has to be positive, or in this case has to be greater than -6. And we have to look at this piece here, which would be x plus 2 greater than 0, or x greater than -2. If I put this on a number line, so -6 to -2, then as you can see, if it has to be greater than -6 and it has to be greater than -2, then basically it has to be greater than -2, right? Because we can't use -5 plugging into this one. And so our domain then would be the x is greater than -2. All right, now we can go through and try to solve this. So since I have the same bases, then what I can do is I can write my x plus 6 times, why is it times? Because that's being added, and equals, but if I'm using the same base on this side, so basically what I'm doing is base 5, I have to use the same base on the other side, so that would be 5 to the first power. So all I did was write it in the same base. Now I multiply, I do that FOIL thing here, so x squared plus 2x plus 6x plus 12 equals 5. I get x squared plus 8x plus 12 minus 5. I'm going to move the 5 to the other side. So x squared plus 8x plus 7 equals 0. Now we can see, if you remember that algebra stuff of factoring. So I set my two factors equal to 0. I know that's x and x. I know the only way to get 7 is 1 times 7, and everything is positive. So setting both of these factors equal to 0, x plus 7 equals 0. I get x is -1 and x is -7. Now do you see why we like to do this? Because that one you're going to omit because it's not in the domain, and thus that would be our answer. So you have to be careful with these, that you look to see if they're in the actual domain. All right, let's do an actual Ln. So if I want to solve Ln of x, remember that's base e, equals Ln of x plus 6 minus Ln of x minus 4. I can already see my domain. Of course, this first one has to be x is greater than 0, x is greater than -6, and x is greater than 4. Typically, you're going to pick the biggest one, but once again, if you did the number line thing, you'd see. So that is my domain. So I'm going to kind of do the other thing where I did the 5s, but on this one, I'm going to do e's. So in other words, if I'm taking each side, I should say, and doing e to that power. Why am I doing e? Because that's my ln. I get x equals x plus 6 divided by x minus 4, because once again that's a quotient, or a difference I turn into a quotient. So to solve this, I would move the x minus 4, multiply it to the other side. I get x squared minus 4x. Let's just go ahead and move everything to one side. And so that gives me x squared minus 5x minus 6 equals 0. I try to factor that. I get x and x. It looks like 6 and 1, and the negative has to go on the larger value since the 5 is negative. And thus I get x plus 1 equals 0, or x minus 6 equals 0. X equals -1, or x equals 6. Looky. We omit that one for not being in the domain.